Hi everybody, tonight's video is going to be on interpreting functions. And we've already kind of talked about just a general introduction to functions and their graphs, but now we want to be able to gather more data and more information just from looking at the graph of a function. Reason for that is a lot of times we're going to use functions to model real-world data, so it's going to be important for us to be able to look at a graph or look at a function and its equation and interpret what it means. So for example, if a function is representing the outcome of some events over time, we're going to want to see what happened in a specific year. So we're going to want to be able to plug into the function for a certain year and determine what that outcome is that's modeled by the function's equation. So, for example, if I have some sort of equation for a function, f of x equals 2x squared plus 4, and we've been evaluating it, but just like algebraically, we've said, okay, find what f of 3 is. And you would take 3 and you would plug it in for x, and you get 2x squared plus 4, in this case 2 times 3 squared, which is 2 times 9, which is 18, plus 4 is 22. So we've just been evaluating in the past, but when we really want to interpret this, what we want to think of is that when x equals 3, f of x equals 22. That's what this means. This means when you plug in 3 for x, the value of the function, f of x, equals 22. We can also think of that as a point on the graph of f of x, and that would be the point 3, 22, because x is the x coordinate, so x equals 3, and when we evaluate for f of x, and we plug in a value there, f of 3, the corresponding value, the 22, is the corresponding y-coordinate for x equals 3. So 3, 22 is actually a point on the graph of f of x. So we can evaluate these functions for different values of x, and that actually gives us a point on the graph. That's similar to what we've done before when we graphed equations, where we'd make a table and we'd have a column of all the x values, and then we'd plug it into the equation and we'd come up with a column of all the y values, and then we would take the x and the y and we'd make an ordered pair out of it and plot that as a point. So we've kind of done this before. But we're going to want to be able to translate between, okay, this is what it means to evaluate a function, or when I take x equals 3 and I plug it in. If I find a point on the graph, like if I looked at this point, 322, I would say that the function value is 22 for x equals 3. So we're just going to want to be able to work back and forth from either being told the point and realizing that it represents something like this, or being told x equals 3 and evaluating and realizing that it represents the point. So we're going to be working algebraically and graphically, and we're going to be doing a lot more working with a lot more values of the different parts of a function and the different graphs. So we're going to talk about maxima and minima and stuff like that. We're going to do that later. For now, what we're going to do is answer some questions about these values for a specific function. So let's consider this function p of x equals negative 2x squared plus 3x plus 5. So we can use this equation, we could use the graph, or we could use a table of values to help us answer questions about p of x. So that's what I was trying to say here, where we're going to be going back and forth between what all of these different things represent. The graph, or the function equation, the graph, and then these different evaluations for f of x. So consider p of x. And now we're going to want to answer some different questions. So find p of 0, p of 4. Is p of 2 positive or negative? On what interval is p of x positive? And where does p of x equal 0? So I want you to pause this, write all of this down, because after this I'm going to switch over to our graphing calculator. And so you want to have these questions on the side, and then we'll be working out the answers on that. So maybe take a second, pause this, and then write down everything you see on this screen, and then I'll switch over to the graph. Okay, so if you have everything written down, let's switch over to the graph here and try to answer some of these questions. So here we go. We're using our Desmos web app. You might have it downloaded on your phone or iPad or iPod, whatever. But let's take a look at this. So here's my graph, and I want to answer those questions. Find P of 0 and P of 4, first of all. So I could do this algebraically. I could plug in 0 for x and evaluate this equation. So if I want to do that down here, I would write P of 0, and that gives me 5. It tells me that the answer to that is 5. Or if I want to do that graphically, I can go over here and I can see P of 0. Remember what we just said that represents. That represents P of 0 is the y-coordinate for when x is 0. So let's find the point where the x value is 0. If I look up here on my graph, the y-coordinate or y value is 5. So I can determine that either by evaluating P of 0, looking at the point that's on the graph where the x-coordinate is 0, or I can use a table like we used to when we were just graphing equations, and here's where x equals 0, here's P of x equals 5. So there's actually like 3 places I can look for the answer of P equals 0. The other thing it wanted was P of 4. So I could take P of 4, put that in, and here we have negative 15. So if I put in P of 4, over 1, 2, 3, 4, it actually drops off my screen, it looks like. And yeah, it's way off here because there's 3.9, and then it goes off the screen. Here we could keep using our table, and we would see that P of 4 equals negative 15. The other option, like we did, was just plugging it in. So here, unfortunately, it drops off the screen. I suppose we could move this around. There we go. And now we found P of 4 is down here at negative 15. Okay. What are some other questions that we have written down? Is P of 2 positive or negative? So P of 2, I could plug that in and evaluate it and determine if that answer is positive or negative. P of 2 is 3. Okay, it's this point right here. So is that a positive or negative number? P of 2 is 3, so 3 is positive, so I would say P of 2 is positive, right? It's just asking for the value of the graph, or the value of the function at where x equals 2. Okay, so yes, we would say P of 2 is positive. Then it wants to know what interval is P of x positive. Another way you might see that written is what interval is P of x greater than 0. That's another way to say P of x is positive. So you might see P of x greater than 0. Not equal to, right? Because if it's equal to 0, that's not positive, that's 0, right? So if this is P of x greater than 0, if you see that, that's saying positive. And if you ever see something written out like P of x less than 0, that's another way to say negative, right? So positive is greater than 0, negative is less than 0. Okay, and it's asking us on what interval. So remember, we're going to want an interval notation. So let's take a look back at our graph. What interval is P of x positive? Okay, so the graph, it's asking the values of P of x being positive. So where are all the y coordinates positive? What interval are those all positive from? And it looks like right here at negative 1. And then let's see if we can get our gray dots up here. Because remember, those tell us the intercepts. So it's at 0 at negative 1, and then it goes up. So that's all positive. Those are all positive y values. And then it hits 0 again at 2.5. So after that, it goes back into the negative y value. So it's negative from there to there. So the interval on which this function p of x is positive is -1 to 2.5. And so when we go back and we would say on what interval is p of x positive, I would write this as -1 comma 2.5. And I'm using parentheses here because it's open, right? If this was a closed interval and it included -1, I'd use the bracket, but it doesn't include -1 because at -1 it's actually equal to 0, and we want it just where it's greater than 0 or positive. We don't want it equal to. So that's why I'm using parentheses. And it goes from -1 to 2.5. Okay, this is confusing because it looks like an ordered pair, but in interval notation, it's saying from here to here on the x-axis, and this is open because we have the parentheses and we don't want to include these numbers because that's where they equal 0. We just want it greater than 0. Which leads us to our next answer. Where does p of x equal 0? It equals 0 at x equals -1 and x equals 2.5. If you looked at the graph to get that answer, here we go. It equals 0. So where is the p of x equals 0? At -1 and 2.5. Okay. Wonder if we could type that in here if it will tell us those two values. Let's see. P of x equal 0. No, I think it just nulled p of x. Okay, so so I don't think we can do that from Desmos. I could check and see if we can find that later. But for now, we would just have to rely on checking the points or checking our table value wherever I see it equal to 0, -1. But in that case, we'd have to be careful because there might be an x value that gives us 0 that isn't listed here. So that's why it's always good to check the graph. So here, p of x equals 0. Another way to say that is where are the x-intercepts, which is where y equals 0. So where are the y values equal to 0? And that's at -1 and 2.5. Okay, so we'll play around with this a little bit more in class. We'll have some pictures of graphs in our books, and it'll ask us different questions like this. So we'll have to be able to look at the graph and determine from these points or from a table or from a given equation what these different values are, and we'll do some practice problems like that tomorrow. So hope you have a good night, and see you then.